In this video, we're going to talk about posters. A rectangular poster includes a printing area and margins all around, and it has an area of 1,014 meters squared. The top and bottom margins are each 2 meters, and the side margins are each 3 meters. We want to find the dimensions of the poster, giving the maximum printing area. So we have a picture of the situation here. We're going to let L refer to this overall length, and we're going to let W refer to this overall width. Okay? So we're trying to maximize the interior shaded area. Now, the interior shaded area has an area of L minus 6 times W minus 4 because L refers to this length. So since we have margins of 3 on the left and right, the length of the printing area will be L minus 6. And W refers to this overall width. So since we have margins of 2 and 2, the width of the interior rectangle will be W minus 4. So that printed area, we need a formula for it, and it's equal to L minus 6 times W minus 4. And when we distribute and collect like terms, we ultimately have LW minus 4L minus 6W plus 24. Now, we know that LW is 1014 because L refers to the overall length and W refers to the overall width, and the area is 1,014. So since LW is 1,014, that means L is 1,014 over W. So we're going to take that expression for L and plug it in for the L's up there. And when we do that and we collect like terms, we ultimately get a printing area as a function of W equaling 1,038 minus 4,056 W to the negative 1 minus 6W. Okay, now to determine the domain in this question is actually rather interesting. We know the minimum possible width of the rectangle is 4 because, now the reason for that is width refers to this vertical line. Now the width of this little interior smaller vertical line could theoretically be 0, or as close to 0 as we could imagine. But the larger width, the W that we're using in our formula, still has to account for a margin of 2 on the top and the bottom. So even if this shorter vertical line was virtually 0, this larger vertical line would be virtually 4. So we know that 4 is going to be less than W. Now, to determine the maximum value for W is a little bit more complicated. But what we're going to do is we're going to think of the minimum value for L. Now, L refers to this horizontal line. Okay, well, the maximum value for the vertical line will occur when we get the minimum value for the horizontal line. Now, we know that the minimum value for this interior horizontal line could be virtually 0. The longer horizontal line would still have to accommodate a 3 and a 3 on both sides, meaning that that longer one would have to be at least equal to 6. So our minimum length we could call 6. And if we did that, our width would be 1,014 over that, which would be 169. So we can see that our domain ultimately is going to be 4 less than W less than 169. Okay, so as we go through this, these are what we're saying. If we let the length be a minimum, then 6 is 1,014 over W, W is 169, and we get a domain of 4 less than W less than 169. Some people prefer to say 4 less than or equal to W less than or equal to 169. That's okay too. Okay, so now going back a few slides, recall that our formula for printing area as a function of W is 1,038 minus 4,056 W to the negative 1 minus 6W. So again, we'll say 1038 minus 4056 W to the negative 1 minus 6W. That was our formula for printing area as a function of W. Well, if we determine the derivative of that, we ultimately get 4056W to the negative 2 minus 6. And if we set that equal to 0, and we do a little algebra multiplying both sides by W squared, ultimately we get that W will equal plus or minus 26. We get 4056 equals 6W squared, dividing by both sides by 6. W's plus or minus 26. Now, common sense tells us the W cannot be negative, but another way to think of it is that our domain, if you go back a few slides, was 4 less than W less than 169. So however it is you choose to think of it, we realize that the only valid answer there for W is 26. So what we're going to do is we're going to determine what is the printing area when W is 4, and we're going to determine that by plugging 4 into our printing area at W formula. We're going to plug 26 in there as well, and we're going to plug 169 in there as well. And when we do all those plugins, we see that when we let the W be 26 and we plug into the printing area formula that we got a few slides ago, we get our maximum possible area of 726. Now, the question says, what are the dimensions of the overall poster? Well, the W that we just found is the width of the overall poster. We know that'll be 26. So all we have to do now is figure out what's the length of the overall poster. But keep in mind that we know that L times W is 1014, or in other words, we know that L is 1014 over W. And so all we're going to have to do is take this 26, plug it in for W right there, and determine what L should be. When we do that, we get L is equal to 39. And so the dimensions of the overall poster that maximize the printing area are a length of 39 meters and a width of 26 meters.